back, guys. Welcome to this page of the notes. Now what we're going to do is we're going to start with that second objective where we're going to learn we're going to review a number of factoring techniques that you guys would have learned in Algebra 1. But before we take a look at those factoring techniques, once you've got your factors, I may in some cases ask you to solve. And I just want to remind you of this zero product property again from Algebra 1. It's what we're going to use to solve once we've done our factoring. So let me go ahead and highlight this for you. This is going to be really important. As far as how you use it, super easy, but I just want to review it with you anyway. And here's the way it's going to work. If you have two factors, A and B, and they're equal to 0, well, that can only happen if either, right? If you have two things multiplied together and they're equal to 0, that'll only happen if either A is 0 or B is 0. So here's what you're going to do in order to figure it out. If you have A, oh, sorry, not my highlighter, I don't want the highlighter. If you have A times B is equal to 0, you're just going to split them up and do A is equal to 0 and B is equal to 0. And what you will have done then is solve. So here's what you guys are going to come up with. We're going to wind up learning factoring techniques so that you wind up with factors. But those factors are going to be equal to 0 because remember, quadratics in standard form are set equal to 0. So once you've factored, you're going to wind up with these factors that are equal to 0. And what the zero product property says is that if I ask you to solve, you will just simply take each of those factors and set them equal to 0, right? This is just like this. If you have x plus 3, the quantity x plus 3, and the quantity x minus 5, and it's equal to 0, well, that can only happen if either x plus 3 is equal to 0 or if x minus 5 is equal to 0. Just like up here, same thing right here. So that's how the zero product property works. Once you have those factors, split them up, set them both equal to 0, and solve. Right? And so what we would wind up with, x plus 3 equals 0, you'd subtract the 3 to the other side, x is a minus 3. X minus 5 is equal to 0, add the 5 to the other side, and we find that x is equal to 5. All right, so zero product property, if I ask you to solve, you'll use the zero product property to go ahead and do that, and we'll practice that again a little bit later on. What we want to do is we're going to go ahead and jump into our very first factoring technique. Now, before we take a look at our first factoring technique, what I want to do is give you sort of a broad overview of what we're going to do for the rest of this set of notes, and here it is. Let me go ahead and give you all of the factoring methods that we're going to look at, right? So let me give myself a little bit of space right here. All right, we're going to look at a number of factoring methods, and we're going to look at them in this order. So these are going to be factoring, factoring methods. Now, the first one that we're going to look at is we're going to look at finding a GCF. Now, the reason that they're going to go in this order is because we're going to start with the easiest factoring technique and work our way down to the more difficult ones. So what you're going to want to do when I give you a factoring problem, you will always start by looking for a GCF. It's the easiest method. Start there, right? There's no reason to jump down to method number 4, which is really tricky, when GCF works, right? We want to work smarter, not harder, right? So we'll start with GCF. If I have a GCF, we'll factor using a GCF. If I don't have a GCF, then we have to move on to the next method, which for us is going to be a difference of squares. Now, again, Difference of squares, a little trickier than finding a GCF, but still, in the order in which we're going to do factoring, it's quite a bit easier than option number 3 or option number 4. So I would absolutely want to choose difference of squares over 3 or 4 if I can. So if GCF doesn't work, difference of squares is going to be our next best option. But what if neither of those work? Well, then we have option number 3, which is going to be perfect square trinomials. Perfect square trinomials. And again, perfect square trinomials, a little bit trickier method than GCF or difference of squares, but again, if neither of these two work, it might be the way to go. And then option number 4 is going to be just factoring general trinomials. Of the 4 methods, it is the trickiest one, but sometimes you won't have a choice. So, general trinomials. Now, in this set of notes, in these videos, these are the only 4 that we're going to do, right? But a little bit later on, in later sections, we're actually going to pick up 2 additional methods for factoring. So these are going to come later. So this is going to be, these guys are going to be in this set of notes. But in a little bit later chapters, we'll pick up 2 more methods. Option number 5 is going to be what we call completing the square. And then finally, the last one that we're going to look at, your final 6th option as a factoring method for a quadratic, is going to be the good old trusty quadratic formula. Let me slide up a little bit more here so I'm not squeezing myself in. Quadratic. And yes, you guessed it, the quadratic formula is that trusty old x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac, all divided by 2a. And again, this may look slightly different than what you guys have seen in the past. You may have seen it written as negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. I actually don't care for the quadratic formula being written in that form. I like this one a lot better, and it's because you should, based on the sections we just looked at, you should recognize that negative b over 2a. Oh yeah, that negative b over 2a was how we found our axis of symmetry. Holy cow, are you kidding me? You mean that? Absolutely. We'll get to that when we get to the quadratic formula. I'm super excited to show you how all that works. But again, remember what I'm doing here is I just wanted to give you guys just a quick overview of the different types of factoring methods that we're going to look at here in this set of notes. So let me go ahead and get rid of all this, and we'll start with that first option, GCF. So here we go. Get rid of that. Slide all this down. Here's my factoring technique. Boom. There we go. All right, let's go ahead and jump right into this. For those of you who need a review on it, what it is, remember GCF just simply means pull out the greatest common factor, all right, that all of your terms have in common, right? So here we go. I have x squared plus 8x is equal to 0. I'm going to check for a GCF first. What is the greatest common factor I can pull out of a 16x squared and an 8x? Well, 8 goes into both 16 and 8, so I can pull an 8 out of both of those. I have an x squared and an x, so it looks like I can also pull an x out of both of those. So that's what we'll do. Oh, sorry, hang on, that's my highlighter, I don't want that. I'm going to pull an 8x out of both of these terms, and when I do that, 16x squared divided by an 8x, well, 16 divided by 8 leaves me with a 2. X squared divided by x leaves me with an x. I had an 8x. I pulled out the 8x, which means 8x divided by 8x is a positive 1. So plus 1, and it's all equal to 0. Congratulations, you just factored using GCF. At this point, if I asked you to solve, you would simply use the zero product property to do 8x is equal to 0, and 2x plus 1 is equal to 0, and you would solve both of those. But I didn't ask you to solve, I asked you to factor, so we're going to stop right there. All right, let's go ahead and try another one. What is the GCF of 20x squared and 15x? Well, yeah, it looks like the biggest thing I can pull out of both of those would be a 5x. So let's go ahead and pull out a 5x. If I pull a 5x out of 20x, 20 divided by 5 would be 4. X squared divided by x would leave me with an x. 15 divided by 5 would be a 3, so plus 3, and an x divided by x would just be a 1. 3 times 1 would be 3. So I just have a 3 there, and that's all equal to 0. Awesome job, guys. You're on a roll. Let's keep going. I got a couple more for you here. This one, what can I pull out of a 4y squared plus 16y? Yeah, it looks like I can pull out a 4y. So we'll go ahead and pull out a 4y. That's going to leave me 4y squared divided by 4y leaves me with just a y. And 16y divided by 4y, well, 16 divided by 4 would be 4, so plus 4. Y divided by y, they go away, and so I'm left with the factors 4y, and the quantity y plus 4 is equal to 0. One more for you here. I got a 6 times a to the 5th plus 18 times a to the 4th. And it looks like I can pull a 6a to the 4th. When I do that, 6 divided by 6 is 1. A to the 5th divided by a to the 4th leaves me with just an a. 18 divided by 6 would be 3. A to the 4th divided by a to the 4th, that goes away, and so I'm left with a plus 3 is equal to 0. Right? So GCF, a really, really simple method for factoring. You just look for the greatest common factor, both a number, a constant, and a variable, if there is one, that all of your terms have in common. Pull that GCF out. Sometimes it'll just be a number. Sometimes it may just be a variable, right? Whatever those terms have in common, that's what you're going to pull out, and then you'll just write the remaining, what's left over in each of those terms inside of those parentheses. Guys, that takes care of GCF, our first factoring method. Head on over to the next page of the notes, and we'll take a look at option number 2. I'll meet you there.